Hey everyone, welcome. Today we're going to dive into a concept that's at the very heart of how AI learns, but it can feel a little, well, complicated. It's called the loss function. This is the real engine behind how an AI gets smarter, and we're going to break down exactly how it all works.
It really all comes down to this one simple question. Think about it. When an AI is training, looking at millions of examples, how does it get any feedback? How does it know if it's on the right track or just completely lost?
Well, the answer is this clever thing called a loss function. The easiest way to think about it is like a mistakeometer for the AI. It follows one really simple rule. If the AI makes a huge mistake, it gets a big loss score. If it makes a tiny mistake, it gets a small one. And the AI's whole job, its entire mission during training, is to get that loss score as low as it possibly can.
To really get a handle on this, let's bring it back to an experience I'm pretty sure we've all had.
So imagine you just took a test. The actual correct score, the perfect answer, is 80. Now the AI, our student in this little story, it makes a prediction. It guesses 70. So you can see there's a clear gap there, right? Between what's correct and what the AI guessed.
That gap, that difference of 10 points, that is the loss. It's just one single number that tells the AI precisely how far off it was. Now it has something real, a score for its mistake.
Okay, so let's take this idea out of the classroom and see how it works in a real-world scenario that AIs tackle all the time.
Let's say we're training an AI to predict how much houses are worth. We give it a bunch of info on a specific house, and we know for a fact that it actually sold for 50 lakh rupees. That's our ground truth.
So the AI does its thing, it crunches all the numbers, and it comes back with a prediction, 45 lakh rupees. Now that's pretty close, but it's not perfect. So you know the question, what's the loss here?
The loss is a clean 5 lakh rupees. And this is so important. The AI doesn't just know it was wrong, it knows exactly how much it was wrong by. Its mission just became crystal clear. Do whatever it takes to make that number smaller on the next try.
So here's where it gets really cool. That loss value isn't just some final grade it gets. No, it's the actual fuel that powers the entire learning process. It's what kicks off this incredibly powerful feedback loop.
And this slide shows that loop perfectly. It's a constant cycle. Step 1, the AI makes a prediction. Step 2, it compares that prediction to the real answer. Step 3, it calculates the loss, how far off it was. And then the magic happens in step 4. It actually adjusts its own internal wiring to try and shrink that loss number. And this cycle doesn't just happen once or twice. We're talking millions, sometimes even billions of times.
Without this feedback, AI training would be completely useless. It's just like the source material says. It would be like trying to study for a huge exam but never ever checking if your practice answers were right. You'd have no idea if you were learning anything at all. The loss function, it's the answer key.
Okay, but here's the thing. You wouldn't use a hammer to fix a watch, right? Same idea in AI. You use different loss functions for different kinds of problems because not all mistakes should be measured the same way.
So let's peek inside this toolbox. For predicting a number, like our house price example, you might use something called mean squared error. The key thing to know about this one is that it really hates big mistakes. It actually squares the error, so being off by 20 lakh is treated as way more than twice as bad as being off by 10 lakh. It forces the AI to avoid those crazy, wild guesses. But what about a simple yes or no question, like is this email spam? For that, you might use cross-entropy loss. This one is super clever. It doesn't just care if the AI was right or wrong. It also looks at how confident the AI was. A wrong answer with high confidence, that gets a massive penalty. And then, sometimes you just want to keep it simple, and that's where absolute error comes in. It just measures the simple difference. Nice and straightforward.
Okay, so what does all this actually look like in practice? And maybe more importantly, where is this whole field going? Let's zoom out and get the big picture.
This chart right here, this is basically a picture of an AI getting smarter. When this training first starts, that loss is going to be super high, right? The AI is just guessing, making tons of mistakes. But as it goes through that learning loop over and over and over again, you see that loss bar just plummet. That graph is the signature of a successful AI training session.
When you boil it all down, the goal is just dead simple. Make the loss go down. And the mathematical engine that actually does the work, the thing that figures out which internal knobs and dials to turn inside the AI, that whole process is powered by something called optimization.
And believe me, this is not some old, dusty concept from a textbook. This is happening right now.
The top minds at places like Google, Microsoft, and OpenAI, they are literally inventing smarter, custom-built loss functions as we speak. They're designing functions that can help reduce bias in AI or handle the messy, noisy data you find in the real world. This is where a ton of AI magic is being made today.
All right, so let's bring it all home with one final, super clear definition. A loss function is just a mathematical ruler that an AI uses to measure its own mistakes. It's the guidepost that lets it systematically improve and get more and more accurate, one prediction at a time.
And that leaves us with a pretty big question to chew on, doesn't it? If an AI's entire path to getting smarter is all about reducing its loss, then who's the one that gets to decide what counts as a mistake in the first place? The answer to that question has some huge implications, and it's something we're all going to be thinking about as these systems get more and more powerful.